Now that we know how to use long division and synthetic division to factor polynomials, let's take a look at a special case, or two special cases actually, but they're related to each other. Sums of cubes and differences of cubes. Now you already heard of difference of squares before, so there's going to be some sort of tie into that. Let's start by doing a bit of an investigation though. If I ask you to factor x cubed minus 8, then hopefully at this point you've got an idea of how to approach it. You want to look at the 8 and go, okay, what are the factors of it? So let's just write these over on the right. So factors of 8, the constant term, are 1 and 8, 2 and 4, and that's it. And of course, plus or minus for each of them. We know that if we want to look for factors, and we generally start with 1. So let's try what happens if I put 1 in here, f at 1. Well, 1 cubed is 1 minus 8. That's not equal to 0. That's all I care about, whether it's equal to 0 or not, right? What about f at negative 1? Well, obviously that's not going to work either. That's not going to be equal to 0. I'm going to have negative 9. What about 2? I mean, this is such a simple polynomial that we can predict by looking at it that, yeah, 2 is going to be a good one. F at 2 is going to equal 8 minus 8, which will be 0. So that means that that x minus 2 is a factor, right? We know that. X minus 2 is a factor, and therefore we can, if we try synthetic division, this is a situation where we can use synthetic division. We'd set it up like this. We'd go 2, and then inside the box we'd have 1, 0, 0, negative 8. Remember, these two zeros are placeholders for the x squared term and the x term that aren't there. So we have to keep those placeholders. Going through synthetic division, we get, bring the 1 down, multiply by 2, add, multiply by 2, add, multiply by 2, add, right? That's the beauty of synthetic division, is it gets fast when you practice it. Remainder, then we have coefficients. These guys here are the coefficients for the answer. So we know that x cubed minus 8 is equal to x minus 2 times 1x squared plus 2x plus 4. And in the past, we'd look at this here, this quadratic, and say, does it factor? Because if, what are two things that are going to multiply to give 4 and add to give 2? And you think about that for a few seconds, and you generally, hopefully, come to the conclusion that nothing nicely multiplies to give 4 and adds to give 2. So what else could we do? We could use the quadratic formula, or we could even, before we jump to using the quadratic formula, we could just check by using the discriminant. Remember that b squared minus 4ac? Just to see if there are any roots. Maybe there are no roots here. So that would be 2 squared minus 4 times 1 times 4, which equals negative 12. And remember, when the discriminant is a negative number, that means no roots. What that's telling me is that we can't factor what I've highlighted in yellow anymore. And we can confirm that on Desmos too. If I go to Desmos, y equals x squared plus 2x plus 4. I think that's what it was. Let's just confirm. Yes. And look what we get. We get something that doesn't touch the x-axis. If it doesn't touch the x-axis, it has no zeros. It has no solutions. Can't be factored. So that part can't be factored. So this, it turns out, is our final solution here. Actually, let's put the box around the whole thing. So x cubed minus 8 is equal to x minus 2 times x squared plus 2x plus 4. The quadratic can't be factored anymore. All right, let's try the same approach for x cubed minus 1. Obviously, I hope, if I put 1 in, then that's going to work because 1 cubed is 1 and 1 minus 1 is 0. So we know x minus 1 is a factor, and we can substitute x equals 1 in to get our, well, to use synthetic division. So if I put 1 out here, and again, my coefficients would be 1, 0, 0, negative 1. Again, putting placeholders in for x squared and x. Going through the synthetic division. This is what I get. This is my remainder. And so in factored form, I have x cubed minus 1 is equal to the first factor I found, x minus 1, times the quadratic that comes from these coefficients of 1x squared plus 1x plus 1. And it seems that we run into the same problem again when we try to factor this quadratic to break it down further. What two numbers multiply to give 1 and add to give 1 as well? Well, I could again try the discriminant, but let's just go to Desmos since we got it handy here. Once again, we see that our graph does not touch the x-axis, has no zeros. If I were to do the discriminant, I'd get a negative number again. There'd be no more solutions. So once more, we're stuck. This is as far as we can go for factoring this. Let's try one that's a little bit more tricky looking. Is x minus y a factor of x cubed minus y cubed? This still looks like a difference of cubes, right? These have both been differences of cubes. In other words, remember difference of squares. The difference of squares was two perfect squares with a minus sign between them. Well, difference of cubes is two perfect cubes with a minus sign between them. X cubed is a perfect cube. 8 is also a perfect cube. 2 times 2 times 2 equals 8, and there's a minus sign between them. X cubed minus 1 is also a difference of cubes. 1 times 1 times 1 is a perfect cube. So here we have a difference of cubes again. Two perfect cubes with a minus sign between them. We can't use synthetic division in this case, though, because we got these two variables going on. This is a case where we're stuck going back to long division. But that's all right. It takes a bit more work, but it will work. So for long division, my divisor is x minus y. My dividend is x cubed. But remember, we have to put placeholders in here again. So I'm going to have minus y cubed on this end, but think about all the terms that would be missing in between. We must have a x squared y term. We must have an x y squared term. And actually, I guess that's it. Unless I'm mistaken, let me just double check and think about that. We went from x cubed to x squared to x, so we've run out all our different possibilities for x. And then we've gone from y to y squared to y cubed. Okay, they're all there. So maybe I didn't need to make it quite so long. Let's move that y cubed over there. So we got these 4 different types of terms. Go through the long division process. Still just divide this by this and see what you get. Well, I get x squared, which I will write above the x squared column. And so then when I multiply, I get x squared minus x squared y. And when I subtract, these cancel out, and 0x squared y minus negative x squared y becomes positive x squared y. Bring down 0x squared y. This is a 1, by the way, it's assumed to be. 0x y squared. Do it again, and I get plus x. So x times each of these terms here will give me x squared oops, sorry, not x. My mistake, it's not just x, it's xy. Let me back up for a second. I was dividing, back this up. I was dividing this whole thing by x. So when I divide, it reduces my exponent on the x by 1, so I'm just left with x, but I originally forgot to write down this y that was here as well. So now I've put it up top. And now that I've done that, I'm going to multiply xy times each of these, and then I'm going to get x squared y, and I'm going to get minus xy squared here and here, respectively. And then when I subtract, these will cancel out, and I'll get a positive xy squared. And then one more time, I'll bring down negative 3y cubed. And when I divide, I'm going to be getting plus y squared here. And then when I multiply, I'll get xy squared minus y cubed. And both of these cancel out, giving me 0, my remainder of 0. So x minus y is a factor because we got a remainder of 0. And in particular, that means that if I started to factor x cubed minus y cubed, I could write it as x minus y times the quotient, which was x squared plus xy plus y squared. But I wouldn't be able to factor that one anymore either, but we're not even going to try. So now that we've looked at a few of these, let's decide if we can see some sort of a pattern going on. And the answer, at least in my eyes, is yeah, there is a pattern going on. All the answers all the factored forms look like what's right below where I'm writing. They look like this. So if we start with a difference of cubes, and let's just call it a cubed minus b cubed, so a and b can be any terms, then it seems like we always just get a minus b times a squared plus ab plus b squared. So here's an example. Let's cover this one up and just go through it together. Okay? In order to actually just put this into effect, we need to realize that we got two perfect cubes. So the first perfect cube is 8x cubed. So in other words, if I were to take the cube root of 8x cubed, cube root of 8 is 2, and the cube root of x cubed is x. If I were to take the cube root of y cubed, then I would just get y. So that's my a and my b values from the formula up above. And so then I'd have 8x cubed minus y cubed is equal to, and I'm just going to follow this pattern here, but instead of writing a's and b's down, I'm going to write 2x for a and y for b. So I'm going to write a minus b is 2x minus y, and a squared is 2x squared, plus ab is 2x times y, and b squared becomes y squared. So I can simplify that a bit, what's inside the second brackets. 2x squared is 4x squared without the brackets. 2x times y is just 2xy, and then we have y squared. So this would be our factored form of the difference of cubes, 8x cubed minus y cubed. And we don't have to go through the trouble of doing long division or doing synthetic division. In other words, what this formula here gives us is a pattern that we can just fill in some numbers for, get our answer if we recognize it as a difference of cubes without having to do all the extra work. Sum of cubes, x cubed plus 1, okay. If we want to factor this one, again, we have to look at factors of 1 plus or minus 1. I think a little bit of thought will quickly show us that if we put negative 1 into that binomial, that's going to give us an outcome of 0. So x plus 1 is a factor. If we do synthetic division, then we'll quickly see here's my remainder that we get x cubed plus 1 is equal to my first factor of x plus 1 times, again, a polynomial or quadratic with those coefficients. So 1x squared minus 1x plus 1, which again is not going to factor anymore. X squared minus x plus 1, two numbers that multiply to give negative, positive 1 add to give negative 1. It just doesn't happen. As you can see, it doesn't cross the x-axis when I graph it. Doing the same thing one more time with x cubed plus 8. Again, hopefully we can, because it's a simple binomial, we can see that f at negative 2 is going to equal 0. Negative 2 cubed is negative 8, plus 8 is 0. So we can see that x plus 2 is a factor. We can go through the synthetic division again quickly. We get our remainder of 0. We see that x cubed plus 8 is equal to our first factor of x plus 2 times 1x squared minus 2x plus 4 from here, from above, which again will not factor. This is actually called, or both of these are called sums of cubes. The only difference between them and the first set of examples we did is that they've got plus signs between the two perfect cubes. What we notice, hopefully, is the same pattern pretty much as above, except that the signs are different. So in the let's put them side by side. So this is sum of cubes. And if I write difference of cubes beside it, that one was a cubed minus b cubed equals a minus b times a squared plus ab minus, also plus b squared. So if you look at these two formulas side by side, the only thing different about them is that one of them is got positives where the other one has negatives, and vice versa. We can then use the formula again if we recognize the different parts. So here's an example. X cubed, that would be so that would give us an a value of cube root of x squared, x cubed. A is equal to the cube root of x cubed, and b is equal to the cube root of 27 y cubed, and that's where we get b is equal to 3y. We can plug them into the formula, simplify things like I did in the previous one. You can see all the work right here at your leisure, so I won't read that through to you. The last thing I just want to tell you about sums and differences of cubes is an acronym to help us remember the formulas. If you remember the acronym SOAP, that'll make it easy. So to do with the signs, they say same, opposite, and always positive. What does that mean? That means that if you look at a sum of cubes, if we've got sum means we start with a plus. So going through these three signs, there's always going to be three signs. The first sign is same. The second sign is opposite, because opposite of this plus sign here is a minus. And then at the end, it's always positive. SOAP. If we look at this one here, we got a difference of cubes. It's got a minus sign. So we've got same. Then we got opposite. So opposite of the minus sign, and then always positive. So if you're needing to remember the formula, you can remember the signs at least using SOAP.